Have you ever wondered why your mom always had you rinse with salt when you had a mouth wound? Well, I always chalked it up to a wise tale our parents raised us on, but turns out it's not. This last semester, when I took microbiology, I took a fascination with halophiles. I was so fascinated that I chose it as my topic today. We are going to learn what are halophiles, why their ability to adapt to hypersaline environments is important, and how they're advancing biotechnology. The world is filled with an unfathomable number of bacteria, good and bad. Like fish need water and humans need the air, different types of bacteria need different environments in order to sustain itself. Extremophiles are a special type of bacteria that can only survive in extreme environments. For example, the mold that grows in your fridge. Your fridge is an environment that is much too cold for normal bacteria to grow. Also, your stomach. Your stomach has a pH of 2. Most bacteria prefer a more neutral environment with a pH of 7. Halophiles are a type of extremophile. Halo means salt, phile means loving, and so we have a salt-loving bacteria. Halophiles prefer an environment from 4 to 40% salinity. The ocean, for example, is on average 3% salinity, and we all know what a salty mouthful of ocean water tastes like. Halophiles prefer an environment like the Dead Sea, which is 34% salinity. Now that we know what halophiles are, let's talk about how their ability to adapt to a saline environment is important. So, scientists are asking themselves if living organisms are not able to inhabit environments like the Dead Sea, then how are halophiles able to do so? What do they know that we don't know, and how can we use this information to better the future? In order to answer these questions, we must first understand what an isotonic condition is. An isotonic condition is when the intracellular environment is balanced with the extracellular environment. If this isn't balanced, the cell will die in a process called osmosis because the water will leave the cell to follow the salinity. Scientists are interested in halophiles in their ability to inhibit these hypersaline environments while making stable enzymes. Halophiles have adapted these processes in order to make themselves stable, called salting in and salting out, which is an accumulation of organic molecules within the cell so that the intracellular environment is balanced with the hypersaline exterior environment. The cell is then able to produce enzymes which allow the cell to do the jobs it needs to do to survive and reproduce itself. Now that we know how they inhibit these hypersaline environments, let's talk about how they're advancing biotechnology. Scientists are looking at halophiles' ability to help biotechnological processes like biofermentation and bioremediation. Biofermentation uses microbes to break down pollution into less toxic forms. With increase in industries such as textile, coal, petroleum industries, they're producing more wastewater, hypersaline wastewater, which contain toxins like ammonium, heavy metals, and hydrocarbons. Scientists are leaning on halophiles as microbes that can break down these toxins in this hypersaline wastewater. Another biotechnological process scientists are using halophiles for is bioremediation, which is the use of biomass such as wood and corn and gas to make renewable energy. So currently, there's a ton of non-sustainable ways to do this, but halophiles are the most cost-efficient and the most renewable way to do it. Scientists are leaning on the halophiles in the bioremediation process because not any bacteria or organism can be put into this biofermentation process, which one of the steps is a hypersaline environment. In conclusion, it's irrefutable that halophiles are advancing us into a better, brighter future. their ability to adapt. We've learned what they are, their ability to adapt, and how they're advancing biotechnology. Thank you.